Hello, this is Memphis Communiversity. Today we are going to be doing some AP Calculus Free Response questions. Today we're doing Accumulation Free Response questions. So these are usually the first free response question that you see. They appear on the AB and the BC exam. So they're pretty important. We of course have difficulty all the way from 1 to 10. So we're sort of in the middle-ish level, difficulty number 4. We do have a calculator here, which is great. So we should be able to just set up the questions, and then we can rely on the calculator to solve them. So in this question, if you've watched our previous videos were on difficulty 2 and 3, of course, and those were rate in, rate out free response questions. So they had 2 rates. In this case, we're going back to just 1 rate. And what I want to focus on in this free response question is the difference between average and average rate of functions. So that's definitely something that a lot of students get confused about. And also I want to focus a little bit about units as well. So for example, we have units here in some of these questions, and units are obviously not the most important part of a question, but they do add up in a free response question. So for example, units in this question probably take 3 of the 9 points, which is fairly significant, and it should be a pretty easy thing. So let's start with this free response question. So I have here my friend Fine Wine. Fine Wine is a person who, while she's very helpful, you can watch her videos on her channel. She has several, and she explains things very well. Sometimes she does like to whine, so that's why her name is Fine Wine. And she has this whininess level. And her whininess is defined as the rate of how often she whines in whines per hour. So on a certain day, this is her whininess. This function right here, and again it is in whines per hour. Remember, we're focusing on units in this question, so just keep in mind that this question is sort of like a rate in, rate out question. Even though the word whininess doesn't have a rate, it is defined as a rate. So even if it doesn't say, well, whininess is a rate in or a rate out, it is a rate. So we'll see that in action. So in this case, the first thing we want to do is we want to find W prime of 12. Well, that shouldn't be too bad because we have a calculator. So all I'm going to do is write W prime of 12. And then I'm going to type this in. Hopefully you can see W on the top there and the givens. So I'm going to get my friend Freddie here. Freddiness is going to help me find W prime of 12. Let's see. Keep in mind that this is the AP Calculus exam, so you want everything in radians instead of degrees as you're typing it in the calculator. So here we have to think, do we want to actually take a derivative here, or do we just want to plug in the number? But of course we are finding W prime of 12, so that's going to be taking a derivative. So we're going to go down to derivative. We're going to write x. You can write either x or t as long as you're consistent throughout as you're plugging it in. And then let's just type in the function. 45 plus cosine. Sorry, I forgot my 3, so let's insert a 3 there. And then let's get out of insert. And then let's write x divided by 5. Looks like we need a second parentheses to close out the cosine, so just be careful when you type this in. And then we want to plug in 12 here. So it looks like it's going to be negative 0.405. So negative 0.405. So let's try to do the first question before we interpret. Let's try to use correct units. So whenever you have a derivative, just keep in mind that you always divide by a time period when you do your unit. So for example, the most common example is particle motion. So particle motion, the units are position is meters. Velocity is the derivative of position, so we divide by a time, so it's meters per second. And then acceleration is a derivative of velocity, so we divide by another time, so it's meters per second squared. So in this case, what we want to do is, if we want to write the units of W prime, we want to find the units of W and then divide it by the same time period. So in this case, W is measured in whines per hour, so W prime of 12 will be whines per hour, or if you want to say whines per hour squared. So this will be whines per hour squared. So basically, even though this looks like just a single derivative, this is actually more like acceleration, because W is like velocity. It is a rate, as we mentioned. So now let's interpret the question. So anytime you take a derivative and you see if it's negative or positive, you just want to say that whatever your function was is increasing or decreasing at that rate. Increasing, obviously, if it's positive, decreasing if it's negative. So what I'm going to say is they like you to mention the time. So at time is equal to 12. W of t, or fine wine's wininess, is decreasing because it's negative at a rate of, and then we're not going to write negative 0.5. We're going to write a rate of the 0.405 because we did indicate that it is negative with the word decreasing. At a rate of 0.405, and again, the units will be wines per hour squared. Great. How is this any different than other free response questions? Well, a lot of accumulation free response questions, they want to know whether the amount of wines are increasing or decreasing. So what you would do there is you would plug in 12 into W, see if that's positive or negative, and that would be the number of wines increasing or decreasing. But in this case, because we were finding W prime, that is the derivative of W, that's going to tell me whether her wininess is going to be increasing or decreasing. So again, not a very hard question, obviously. All we did was take a derivative, and Freddie did all the work for us, actually. So it wasn't too bad. But you just want to be careful of units and what actually is increasing or decreasing. So for example, if you wanted to find W of 12, you would plug this in. Cosine is in between negative 1 and 1, so you would add 45. So W of 12 would be positive. And how would I interpret that? Well, it would be similar to the W prime of 12. W of 12 being positive means the fine wine is increasing her number of wines at t equals 12, and that unit would be wines over hours. So you just want to be careful about what do you want to see is increasing or decreasing, and then in order to determine that, you would find the derivative and see if it's positive or negative. So for example, in this question, we found W prime of 12, and W prime of 12 being positive or negative tells me whether W is increasing or decreasing. And W is increasing or decreasing is actually the rate. So let's do this next question. How many times did fine wine from 0 to 24? So over this time period, this first day, over the entire day. And then of course, let's be careful. When we find our answer, we're going to actually round our answer to the nearest whole number. That is one thing that is probably the easiest part of this question, but students mess it up because they're so excited to answer the integral, to answer the question itself, and then they forget to round to the nearest whole number. So let's do that. And how do you find this? Well, I just mentioned it, but this is a rate, and you want to find the integral of the rate in order to determine how many wines she wined from t equals 0 to 24. This is why it's called accumulation fricks, because if you're given a rate, and here wininess, remember, is a rate itself. It's not actually the amount of wines. Here, wininess is the rate. So when you integrate a rate, that's going to be the net accumulation or the net change of that, whatever you're taking the rate of. So in this case, it is how much she wines. So what we want to do is we just want to integrate from 0 to 24 W of t. And if you want to just write W of t, that's fine. Because they gave you the function, you don't have to actually write this out. But for our case, I'm going to write it out so that you can just see what it is. So all I'm doing is replugging in the original. So again, this is not a very hard question. This entire free response question might be easier than amount questions, actually, difficulty 1, 2, and 3. But really what we're focusing again on are the little things: average, average rate, and unit. So let's just type this in real quick. So what we're going to do is when we go to math, then we are going to go to integral, then 0, 24, and then we're going to type in this function, of course. So it's going to be 45 plus cosine. You can use t's and x's again if you're consistent, as long as you choose the same for your variable of integration. Don't really know what I'm saying now. Let's see. So it looks like I'm typing in this wrong. Just type into the calculator pretty slowly so that you don't mess up, like I normally mess up when I do these. And we're going to get 1065, so it seems like a pretty normal day for fine wine. But of course, remember, it does say round to the nearest whole number. So in this case, we are going to round to the nearest whole number. If you can see it, it's going to be 1065. So I'm just going to write approximate 1065, And what's the units here? Here it didn't ask per unit, so I don't have to put it. But again, it's how many times she winds. So this would be winds, no time period, because it's sort of like the difference between position and velocity. When you integrate velocity, you end up getting either total displacement or total distance if you're integrating speed, and you lose that time period. So when you take derivatives, you always add a time period, meters per second squared. And when you take integrals, it's sort of the reverse. You lose a time period, so it's meters per second squared. Integral of that is velocity, meters per second. Integral of that is total displacement, meters only. So in this case, we started off with winds per hour as our middle function. When we took its derivative, we divided it by time, so it's winds per hour squared. And then when we took its integral, we lost the time of winds per hour. Now it's just winds. So again, all we're doing right now is just being very careful with our units, even in this weird, silly question. So the next thing I want to talk about is I want to talk about the difference between average value and average rate. So this is going to be basically this. Notice the wording of these questions are pretty similar, except we're finding two different things: average value and average rate. And then we're going to, of course, focus on units of measure. So what I want to preface you with is average value and average rate are two totally different things. The important words aren't value, because you can say the average value of the rate of change. The important words are average, so just the word average by itself, or the words average rate. So those are the two questions that students often get confused. And in this question, for example, we're asking you both of them to see if you can know the difference between them. So let me remind you a little bit about average and average rate. So in this question, we're only doing average, so let's talk about average. So the formula for the average value of anything, we call F over a time period A to B, is equal to 1 over B minus A, the integral of F. This is actually similar to the average when you're finding the average of numbers. Remember, when you find the average of numbers, like the average of 10 test scores, for example, you would add up all the test scores, and then you would sum by 10. And this is the same thing. Average value is the summation of the function, which is what an integral is, and then you divide by how many x's there are, which is the length of the interval from A to B. So average value is really similar to average of like just numbers that you've been doing since 4th grade maybe. So just keep in mind that for this function, for this method, average value of f, what goes inside the integral, which is called the integrand, that is going to be f. So for example, if I want to find the average value of g of x, it'd be 1 over b minus a, the integral of g of x. And if I wanted to find the average value of velocity, it'd be 1 over b minus a, the integral of velocity. If I wanted to find the average value of acceleration, 1 over b minus a, the integral of acceleration. So basically, for every single case, you put whatever you want to take the average of in this formula. So right now, we want to find the average value of find winds windiness. That was the original function. So we're not going to take any derivatives or anything when we write this formula out. So the average value of find winds windiness over this time period. So I don't know how to spell windiness. I'll mark that out because that's kind of messy, even though all of it is messy. So we're finding the average value of find winds windiness over 0 to 24. So just be careful, you do need this thing on the front. So it's going to be 1 over 24 minus 0, which of course is 24, 0 to 24. And the big question is, what should I put in this function? Should I put the given? Should I put the derivative of the given? Well, again, whenever you're finding the average value of something and you're setting up this integral formula, you always put whatever you're taking the average of. So in this case, we are finding the average of W from the front. So we're going to put W here. And let me remind you what W is. It's going to be 1 over 24, 0 to 24. And then it's going to be 45 plus 3 cosine t over 5. So 45 plus 3 cosine t over 5. And of course, once we've set this up, even though some students don't like average, once we've set this up, we're actually done. We've done the hard part because we have a calculator. All we have to do is type this integral in. So let's do that real quick. So what I'm going to do is I'm going to write 1 divided by 24 because we have this number in the front times. We're going to go do the integral. So it's going to be integral 0 to 24. And again, what do you put in the integrand when you're doing average? You always put whatever you're taking the average of. In this case, the given. So it's going to be 45 plus, let me remember the 3 this time for the, so 3 cosine x divided by 5. Close this parentheses. That parentheses is for the integrand, and then we have dx, and then we're just going to hit enter. Here it's going to be 44.377. So 44.377. Remember that on the AP exam, if it doesn't say round to the nearest whole number, you should always round to 3 places after the decimal. There's no such things as sig figs or significant figures on the AP exam. Just always round to 3 places after the decimal if you have that many decimals. So now we have to talk about the units. So just keep in mind that, again, when you do average, here the average value of f matches what goes inside the integral, because the average value of f is still going to be the same units as f. It is an average of that. So for example, if you're finding average temperature, the average value of temperature would be 1 over b minus a, the integral of temperature, and then the units would be whatever degrees Fahrenheit or Celsius that particular temperature is in. The average value of velocity, 1 over b minus a, the integral of velocity, and then that units would be in meters per second, because average velocity is still a velocity. So in this case, we are going to find the average value of fine wine's wineliness. This is still a wineliness level, and wineliness levels are defined as wines per hour. So in this case, our units are going to be the same units as the given. It's always the same units as this, because this average is an example of this. So it's going to be wines per hour. It matches the units of the integrand, whatever you're taking the average of. So this is this. So that's my rant on average. So basically, in every hour, she's whining 44.377, which is definitely not a bad day for fine wine when it comes to whining. So we're going to do a very similar question, but it's done very differently. It's going to be average rate. So let me explain average rate a little bit, sort of like how I did explain average value before we do the question. So average rate is somewhat tricky at points, because there's really 2 rules for average rate. So average rate of f, usually it's algebra slope. So calculus slope is the instantaneous rate of f at a time versus average rate over this time period. So anytime you have a rate, it's really slope. So calculus slope is when you want to find the rate at a specific time. Algebra slope is when you want to find the average rate over a time period. So usually it's f of b minus f of a over b minus a. But remember that we're thinking of average and average rate as 2 separate things. But if you think of this as an average question, what are you trying to find the average of? You're trying to find the average value of this rate. So I can do a similar formula for this. So the average value, the average rate, this is the word rate, hope we can tell, is the same thing as the average value of f prime, because f prime is the rate of f. So what you can do is you can set up a similar equation, 1 over b minus a to b of f prime instead. And so these are 2 equivalent formulas for average rate. Either average rate or average value of f prime, they're the same thing, because again, f prime is the rate of f. So this is a colon, by the way, not primes. So you have to decide which formula you want to use. And what I tell my students is that probably 80 to 90% of times, you're going to use this formula right here, because the given will probably be of f. But there are situations where they give you f prime and they want you to find the average rate of f or the average value of f prime, so then you're going to do this. So again, these 2 formulas are perfectly the same. Actually, when you do fundamental theorem of calculus on this function, you would take the antiderivative, f of x, plug in top limit, bottom limit, so you would get this formula. So these formulas are equivalent by the fundamental theorem of calculus. But you have to choose which one, because usually there's one that's easier to do. And again, it's based off givens. So if you're given f and you want to find the average rate of f, then you're going to apply this formula, the easy algebra slope. If you're given f prime and you want to find the average rate of f, which is the same thing as the average value of f prime, then you would do this formula. So what I tell my students is, if it matches, if it quote unquote the thing you're trying to find matches, then you do the integral formula. So again, for average value of f, you put 1 over v and I say the integral of f. I gave you f and I want you to find the average value of f. In this case, it technically doesn't match because we're given, for example, f, and we want to find the average rate of f, which is not the same thing as average of f. What we're trying to find the average of rate of f is not the same thing as the given, so you set up this sort of slope. But if you understand the fundamental theorem of calculus, perhaps none of this argument is sort of useful for you. So let's try to do this question in the context. So it says, what is the average rate of change over y-ness over the time interval? So the question is, do we have the rate of change over y-ness? Do we have w prime, or do we just have our y-ness as the given? Well, as our given, it is y-ness, which is a rate. Be careful, but we're trying to find the rate of change of the y-ness. So what we care about is not the original rate, which is the given, her y-ness. We want to find the rate of change of her y-ness. So all of that is to say is that we are given her y-ness. So w of t is her y-ness. And we want to find her average rate of her y-ness. So we're going to set up this formula, because average rate is algebra slope when you're given what you want to find the algebra slope of. So it's going to be w of 24 minus w of 0 over 24 minus 0. And then we are done. Let's first quickly find this number. So remember, w is written right here, 45 plus 3 cosine of t over 5. So let's do that real quick. So I'm going to plug in 45 plus 3 cosine of 24 divided by 5. That's going to be w of 24. So remember, average rate is usually just algebra slope. So it's going to be that. Then I'm going to change the 24 to a 0. So let's delete 0. Then we're going to have this minus this number, because it's y2 minus y1. And finally, we're going to divide by 24, because it's y2 minus y1 over x2 minus x1. And we get negative 0.114. And let's first talk about the units. Well, average rate is still a rate. As I said before, if you're doing instantaneous rate, that's calculus slope. If you're doing average rate, that's algebra slope. But they're both slopes, so they act like derivatives, which means that the units of this thing right here, the units of algebra slope, is going to be your original units divided by a time period. Just like in the first question, when we were trying to find the calculus slope, the units was the original units. In this case, it happened to be winds per hour divided by a time period. So this units is going to be winds per hour squared. And that's the question. So let's review quickly what we did, and let's again focus on units and average rate. So the key fact is always locate what the givens of your original function is. And once you have that, then it'll be easy to determine the units of everything in the next few questions. So for example, in this case, it's winds per hour. That's what w is. So I know that when I take the integral of w, I'll lose the time period. When I take the derivative of w, I will add a time period, so it'll be w winds per hour. Same thing with algebra slopes of w. It'd be winds per hour, because that's a slope of w. And if I want to find average of w, that's just going to be winds per hour, because the average of anything matches the units of that thing. So in this case, when we try to find w prime of 12, we took a derivative with a calculator, and then we divided by the time period. A derivative being positive or negative tells me if my original function, in this case w, is either increasing or decreasing. So in this case, it's negative, so it's decreasing. Again, when you want to find the accumulation of something when you're given a rate, which is why these free response questions are called accumulation free response questions, what you do is you just integrate, and the units will just be losing the time period. Whatever, there's no divide by the time. So in this case, it's just 1. Be careful to round your answer to the nearest whole number if it asks you to. And then finally, we have the average rate versus average value conversation. But remember that average value is governed by this formula, 1 over b minus a times the integral of f. So when you want to find the average of anything and you're given that thing, you just put that into the integral. In this case, it was w of t. We did 1 over b minus a, the integral of w of t, got this unit, and the average of anything matches the units of that thing because average is an example of that thing. So in this case, w of t's units is winds per hour, if that makes sense. Hopefully it does. Finally, we talked about average rate. Average rate of f is usually algebra slope of f, but if you were given f prime in some cases, rare cases, you would set up an integral formula like this, because again, the average value of anything is 1 over b minus a, the integral of that thing. So if f prime is given, which is the rate of change of f, then you would put that. But in this case, it was algebra slope like normal, because we were given y-ness and we wanted to find the average rate of change of y-ness. So it was algebra slope. And when we did algebra slope, we got this number. And the units of average rate is the same thing as instantaneous rate. We do divide by a time period. So in this case, it originally started with winds per hour. So we did winds per hour squared in this last one. So hopefully this hasn't been too hard of a discussion. Hopefully I tried to explain average and average rate as best as I can. If you want to, you can definitely check out our videos on average and average rate that we have in our channel. Hopefully they will be up by the time you watch it. We sort of go over what's the difference between average and average rate. When do you take the integral? When do you do slope? When do you take the integral of f prime instead? Again, this free response question wasn't too bad. If you just try your best, remember never to leave anything blank, of course. You don't know where they're going to give you points. But in this case, what we were trying to do is we were trying to be sort of superstars. I'm sure that you can do these simpler questions, finding W prime, finding W, things like that. But we're trying to be superstars. We're greedy people. We want to be able to get everything right, even if 2/3 on the AP exam is equivalent to a 5. Why don't we try to get 9 out of 9 on some of these free response questions? And hopefully, as you continue to watch these free response videos that we've made, as we go from difficulty 5 through all the way up through difficulty 10, you'll be very comfortable in these accumulation free response questions, whether it be one rate or rate in, rate out, whether you have a calculator, not a calculator, sorry, I can't even pronounce the word, calculator or not a calculator, whether the amounts the given thing, whether the rate in, rate out is piecewise. You'll be comfortable in all these situations so that you'll really dominate these accumulation free response questions, which appear in most years. So hopefully this was helpful. Thanks again for watching my course. Really appreciate your support of our channel as you watch our videos, and I hope to see you next time as we do difficulty number 5. I believe that video is going to be a non-calculator rate in and rate out free response question. So until then, thanks again for watching.